All right, so this is our final project of the walker. Our project overview here. Problem statement was to create a mass market, universal, more compact walker for easier use and less storage. Um, the need was that most walkers only fold in one direction. They're bulky, they're difficult to store, and so we knew that there was a need for an easier and better design as far as folding would go. Um, and then system requirements, we just have like a safety manual, general education on that. As far as the engineering specifications, we have a few requirements that we want to get to. We want to get a foldability, so we were designing a double hinge folding mechanism. Our ease of folding, we were going to hit that by using a spring-loaded folding mechanism. Reliability, we're going to use a high-strength aluminum. And then lightweight, we wanted it under 12 pounds. We want to support up to 400 pounds for the person using it. And then we want to keep the cost under 170. So for our research and results, we believe that the current walkers are too difficult to unfold and they're way too large when needing to be stored. We also found that a lot of walkers require outside help in order to get them folded, a little bit more assistance with that. And they're just kind of awkward and hard to fit inside of an average trunk or sedan. And so for our design and manufacturing constraints, we knew that the geometry of the sliding mechanism would be the hardest obstacle to cross because our component doesn't just slide up and down or side to side. It uses a unique slope, and if it wasn't designed properly, there'd be a lot of friction. It would maybe not slide all the way up or all the way down. It could easily get stuck along the track. And then as far as manufacturing constraints, we knew that because of those issues, we would have to monitor the tolerancing on this particular piece so that way the sliding isn't too loose or too tight. If it was, poorly manufactured here, we'd end up with, I'm sure, a few defective products that might grind or catch when trying to slide into place. So this is our design here, showcasing our dual axis folding mechanism. As you can see, it folds on the sides and it folds at the top, and then it creates this nice cane-like form that makes it much easier to store and put in, relatively tight places. So potential problems that we kind of had to put some thought into in order to guarantee a great product. The first one was the actual folding design itself. We knew we had to design it to where when the arms at the top are folded inwards, that the leg don't hit each other or clash together. The locking system was also another big potential problem that we had to make sure that it was strong enough that it was going to guarantee that it would be safe for the user to use, as well as that it wouldn't fail or corrode or anything like that, and that was a really big safety issue there. And then another one would be just the factor of safety of the hinge and as well as the locking mechanism that I just discussed, just so that we know that the walker has good structural integrity and isn't going to fail or cause any kind of injury, anything that could cause issues with the user itself. And we know there'd be quite a bit of stress since it's having to support different types of weights of people.
All right, hello, this is Brant, and I'm going to be going over the locking mechanism and the spring system on our walker, some more of the moving parts. So in the locking mechanism, and reference to the picture in the top right, what we're going to have is a simple use of plugs with Phillips head screwdriver tips on top. These will allow the slider on the inside to roll over the plugs and then lock into the one that you have specifically marked to your height. Since the components are inside on the hollow legs, it's really challenging to kind of show a good picture, but how the locking system essentially works. But as you will see in later CAD modeling pictures, it is much more clear. And as for the spring system, Our spring system is definitely essential for the walker to fold up and save the user for having to bend down, unlock the sliding legs. As we mentioned before, it's very important that this is easy to use and compactable. So both are very, very high on the priority list, and so we went after the design on these two parts very rigidly. So the springs are attached to the handles, and they are left in a zero tension state while the walker is in use. We will be using a twisting handle mechanism to load the springs, and it will be more clearly shown in the next slide. And here we go. So as you can see in the two pictures, on the left is the unloaded. So we have the full walker in its unfolded state, and you have the unloaded springs as seen in the two red circles. There's no tension in them, and therefore the walker isn't going to be forced to be pulled upwards. But as you can see, as you twist the handles, and that will be shown in the next slide, but those springs move inward on two little pins that are connected to gears. So they become loaded, and when the user unlocks or presses the button to unlock the legs, they will come up to meet him rather than him pushing them downwards and bending over. So in this next slide, you can see a little bit more closely the pictures. On the top, you have the unloaded springs again, and on the bottom, you can see the twisting motion of that handle pulls those two little spring little spring things inwards, and it'll load the springs, and when they press the button, it'll unlock the legs, and the legs will fold upward to meet him. So here's the video. It doesn't have the springs in it, but you can see, if you look closely, I know it's a little bit difficult to see, but that centerpiece is rotating, and it is causing those little spring loaders to move inwards and outwards. So very nice feature. And the handles will also, it is important to mention that the handles will remain in the locked position until the loading of the springs is required, and then they will unlock the handles and twist them up to load the springs. And it's a very easy, efficient way to do it. And yeah.
So here's our function diagram. We have, of course, the walker, and then we have two main parts, which is the body and the folding mechanism. The body would have the aluminum legs, the pivot joint, sliders, front support, handles, and the feet. And the folding mechanism would have in its component level the spring-loaded folding, the double hinge folding, and the button that they would press to fold the walker on either direction. And now we have our Gantt chart, and this is basically just like our planner. We spent most of January just planning and brainstorming what we wanted to do. And then the project definition and concept definition was mainly January and February. Then once we knew what we wanted to do, we started to design, and that was mostly February. And then we stopped because we started doing the other project, but then we decided to do this one. And we would have spent April and the first week of May on the manufacturing process, but unfortunately we couldn't do that. And here's what each of us did, and as you can see, it was pretty spread out, so that was great.
For the procurement plan, we created a table that basically shows all the parts needed in the creation of our walker. Most structural parts are comprised of aluminum. All the data in the procurement plan was obtained from 8020.net, which sells all kinds of parts for diverse projects. Given the cost per unit, the procurement plan allows us to have an estimate of the total cost to make and build a single unit, meaning that this procurement plan would actually help us understand how much the cost would be for example, a prototype rather than mass production. For the manufacturing processes, the manufacturing processes were separated into two categories: individual production or mass production. For individual production and prototyping, we considered using mostly pre-made parts from 8020.net, which would reduce the machining but would increase the price of a single unit. For mass production, we considered direct manufacturing, which is a process commonly used in the electronic and automobile industries. This process would reduce the cost per unit, however, it would be less individual driven.
All right, and this is the final prototype picture. We have, the dual axis folding mechanism. It's really, really efficient for storage space, and I believe it's a great design and greatly improves on the walker's efficiency nowadays and the ease of use. So for our summary and key points, in short, we wanted to design a walker that is simple and easy to use for the older generation, but is much more portable than a walker has ever been. We were able to achieve this with our dual axis design that allows our walker to fold into the size of a closed umbrella. Really, really important that it can fit in the back of a sedan. Structural integrity was a concern when introducing something that folds into something so small compared to when it is in use. However, we found that aluminum was more than capable of achieving the structural integrity that was desired. Our locking and spring mechanism are by far the most innovative component of this entire project, and were designed in a way no walker has ever been before. So really excited about it, and thank you so much, and signing off.